Good day everyone. I am Althea Baldosa and I'm going to discuss on how to find the area of surface of revolution. A surface revolution is formed by revolving a curve around an axis of revolution. These are the formula in calculating the area of surface revolution when you want to work in terms of x. When you're revolving around the x-axis, the area of surface is equals to 2 pi times integral from a to b of the radius in terms of x, which is determined by your curve times square root of 1 plus f prime x squared times dx. And if you're revolving around the y-axis, it's the exact the same formula except the radius is now just x. Let's have this example problem. Find the area of the surface formed by revolving the graph of f of x equals to x cubed on the interval from 0 to 1 about the x-axis. Let's start by drawing our curve. Let's graph the function f of x equals to x cubed and take a look at the curve that's going from our surface of revolution. So I'll draw the y-axis here and then the x-axis and label them. This is the y-axis, this is the x-axis. And now let's graph f of x equals to x cubed. That cube function looks something like this, and this will be labeled f of x equals to x cubed. And then we know that the specific part of this curve that we are revolving about the x-axis is formed x equals 0 to x equals 1, and so this would be x equals 0, and then I'll say that y equals 1 is right about here, which means the point on the curve at x equals 1 will be about here. And so this curve right here is the curve that we're going to be revolving around the x-axis to form a surface of revolution. And so I'll just label that with an arrow so that we remember that what axis we are revolving around. If we revolve this curve around the x-axis, our surface would look something like this. You can see the circles that would be formed, and so we have this surface that looks like it's like the outside of a cone. And so if we want to calculate the area of the surface, we will use the following formula, that the area of the surface is equal to 2 pi times the integral from a to b times radius in terms of x times square root of 1 plus f prime x squared times dx. So let's start setting up this definite integral by using everything that we know about our surface of revolution. So we know that our bounds of integration are the two values of x that our curve lies between. Our curve starts at x equals 0 and stop at x equals 1. So we can have that this is equal to 2 pi times integral from 0 to 1. Now, what is the radius in terms of x? Well, the radius will be the distance from our axis of revolution, the x-axis, to our curve. And this distance right here is r in terms of x. And in this case, that distance is just going to be equal to the function where this curve comes from, f of x equals to x cubed, and rx is equals to x cubed f of x is the function where curve is taken from f of x equals to x cubed, and the derivative of x cubed, f prime of x, will be equal to 3x squared. That's just using the power rule for derivatives. We multiply the exponent down and then subtract 1 from the exponent. So we have 3 times x squared, and so f prime of x is 3x squared, which means that f prime of x squared will be 3x squared times dx. So we have now completely set up our definite integral that represent the area of the surface of revolution formed by this curve revolved around the x-axis. So let's continue solve this definite integral. 2 pi times integral from 0 to 1 x cubed square root of 1 plus 9x raised to 4 times dx. Next is we will be using an integration technique for this specific integral, and it is the u substitution because we have a composite function within our integrand. Square root of 1 plus 9x raised to 4 where the outside function is square root and the inside function is 1 plus 9x raised to 4. To set the inside function of the composite function equal to u, but want to make sure that the derivative of that function can be found within our integral as well. And remember that the derivative of x to the fourth power will be x to the third power. Because of the power rule, we will subtract 1 from the exponent, and so we have x to the third power being multiplied to the composite function. U substitution is going to work here. 9 times 4 is equal to 36. So we have du over dx equals to 36x cubed. And then multiply both sides. So we have du equals to 36x cubed dx. Du over 36 equals x cubed dx. Then we have 2 pi integral from 0 to 1 square root of u times du over 36. 2 pi divided by 36 integral of from 0 to 1 times square root of u times du. Remember that we can rewrite square root of u to be u raised to 1/2, and that will help us to say more easily how we're going to use the power rule of integration. And so we'll have that this is equal to pi divided by 18, right? Because 2 and 36 can both be reduced by a factor of 2. And that will be multiplied by u to be the power of 3/2 divided by 3/2. And that is evaluated from 0 to 1. So the integration rule says to add 1 to the exponent, so 1/2 plus 1 is 3/2, and we divided by that to new exponent. Alright, but then remember that dividing by a fraction is the same as multiplying by the reciprocal of that fraction, and so instead of dividing by 3/2, we can multiply by the 2/3. And so this will be equal to pi divided by 18 times 2/3 times u to the 3/2 power evaluated from 0 to 1. Now, to clean up my work again, we can pull these 2/3 outside and multiply it by pi divided by 18, and then replace u with what we have set equal to, so that we can evaluate it at 1 and then substitute the evaluation at 0. In this case, I'm just going to substitute back for you, and so what we'll have here is equal to 2 pi divided by 18 times 3, which is 54, times 1 plus 9x raised to 4 raised to 3 halves, evaluated from 0 to 1. Alright, so we pulled these 2/3 out, multiplied it by pi divided by 18, and there we replace u with what we set it equal to 1 plus 9x to the 4th power. Okay, now we can evaluate this expression at 1 and then subtract the evaluation at 0. And this will be equal to 2 pi divided by 54. We can reduce that by a factor of 2 in the numerator and the denominator. And we'll have pi divided by 27, and then that will be multiplied by 1 plus 9 times 1 to the 4th power raised to 3 halves, minus 1 plus 9 times 0 raised to 4 raised to 3 halves, and that is equal to pi divided by 27 times 10 raised to 3 halves minus 1 raised to 3 halves. So we have pi divided by 27 times 10 raised to 3 halves minus 1. 1 to the power of anything is just 1. And so this is our final answer. If we plug this into a calculator, an approximate value, you'll find that area of the surface is approximately equal to 3.563 and some more decimals. Either one of these answers is acceptable, as they both represent the area of the surface of revolution found by revolving this curve around the x-axis.